Hi there, this is Kyle again. I've received quite a few questions on my YouTube channel in regards to the control of ESCs within the Arduino environment. So instead of writing sample code into comments for individuals, I thought I would create a brief video that just outlines the bare bones code required to get this working. So, first off you'd want to do would be to include servo.h. Now this is included in the IDE anyway, so there is no need for you to go elsewhere to find the library and put it in your libraries folder. It will be there included in the IDE. You just have to put this one line here. Once you've got this line, you have to create your instance for your servo. So each motor will have its own instance. So you would write servo. I'm going to say motor 1 in one, but if you had more than one motor, of course you'd have motor 2, motor 3, motor 4, etc. But just for this demo, I am going to do just the motor 1. So this, so far, all I've said is include the servo library, and I have one servo for you to worry about. Okay, right, so as we know, all Arduino sketches require the setup parameter. Now in here is where you say where it is going to be attached to. Now I'm using the Arduino Uno within my projects, so I would do motor1 or m1 dot attach, and at this point you would put the pin in here, the pin that you are connected to. Now I know for a fact that pin 6 is a PWM, a pulse width modulation port. It has to be a PWM port, otherwise this will not work. However, you could get around this if you're short on ports by using the software servo library, but I will come back to that shortly. So, and if just a quick tip, if you want to identify your PWM ports by looking at your board, you are looking for this tilde icon next to any of the port numbers. On the Arduino Uno, I believe it is 6, 5, 9, 10, and I believe there are a couple more, but those are the only 4 that I'm using in my project. Right, so at this point now we have said that we are using motor 1 and we have attached it to pin 6 of our Arduino Uno. Now just for fun, I like to put a little delay in, a very brief delay, but this is just enough just to let the Arduino take a breath. It's probably not needed, but I've put one in there. Right. Now then, as everyone knows, the ESCs require arming to be able to work. Now arming is a difficult situation. I'm using Hobbywing 30 amp Pentium ESCs. Now each ESC has a different arming sequence. Most people you'll see on the internet using traditional radios and timers. It requires moving the throttle stick to the lowest and rightmost position to arm them. So, but it's kind of hard to replicate within Arduino. So what you do is you have to find the right angle, and this may be for some ESCs a combination of an angle and a delay, but for the Hobbywing it's quite simple. It's your motor dot right, so you're sending a speed, and it's actually the speed of 40 or the angle of 40. If you were to send this, this is enough to arm the ESC, and then when you connect it up, your Arduino, you will hear the chimes of your LiPo battery count, and then you will have the confirmation that the ESC is armed and ready then to function. So like I said, this scenario I've given you here works for the Hobbywing Pentium 30 amp ESC for brushless motors. I cannot guarantee it will work exactly the same for every ESC on the market, but I'm pretty strong in the opinion that this will work for most ESCs. Now then, you're probably wondering, how do I send throttle? Well, very much similar to what we've done in the setup here. So you will have your loop, and you'll have your motor dot, sorry, not attached, dot right, and then you would put your angle. Like I said earlier, you are sending an angle because it thinks it's a servo, but you are actually, this is your speed. This does mean that the values you can send must be between 0 and 180 degrees, but you will find that this is enough to get your quadcopter off the ground. Now I remember you I mentioned earlier about the software Servo library. Now this is recommended for using more than 6 motors, and because you can use this on any port, it doesn't have to be PWM. Now the difference between that is everything else here is the same, except up here would be, of course, software Servo. You will have to go and download this from the Arduino website. That would become software Servo whatever. But you will also at every 50 milliseconds call software Servo refresh. What that will do is will update all of your servos with their latest values. In the regular servo library you do not have to call this, but on the software Servo you do. I hope this tutorial has been most beneficial for you. I hope it's answered some questions and given you an idea of what's expected. Like I said before, if I can help with anything, please feel free to leave me a question. I'll get back to you as soon as possible. Take care.